I'm Anil Kumar sharing with you a question from the book. It is question number 20, page 76. I've seen this question so many times in the test paper, and it is kind of different from most of the examples you have done so far. The question is, determine the equations of both lines that are tangent to the graph of f of x equals to x squared and pass through 1 minus 3. So that is the question for you. Now remember one thing, this point you can test is not on the function itself. So what is f of 1? Let's figure it out. F of 1 is equal to 1 square, and that is 1. So the point 1, 1 is on the function, right? But not 1 minus 3. So here what we have is an external point, you see. So that is why this question is different. So we have an external point. I have a couple of videos on this. I will provide you with the link, and then you should go through them also, because one of them will be in your test paper. Now read the question once again. Determine the equations of both lines that are tangent to the graph of f of x equals to x squared and pass through 1 minus 3. So this is an external point. So what we really don't know is this external point, when you make a tangent to the graph of y equals to x squared, what are the points on the graph where the tangent is going to touch? So that is not known to us. So what we say is, let the point on the graph be on the graph of f of x be a, and if I write a for x, it becomes a square. So the y value will be a square. You get the point. So this is any arbitrary point on the graph of function f of x equals to x square. So now we just say the point is a square. We still need to find what is the value of a. But once we write that, it becomes kind of easier for us to find the slope for this arbitrary point, right? So we say, what is the slope of tangent line? So we say slope, we can use the difference quotient formula for limits to find this slope, right? So that is limit h approaches 0, f of a plus h minus f of a divided by a. So that is the formula which we are going to use. So let's simplify and use this formula. So limit h approaches 0, f of a plus h means x plus h whole square. So we get x plus h whole square minus f of a means we'll replace this with a square divided by h. Correct. So we could now write this as limit h approaches 0, expand this. So once you expand, some people can factor and then do it also. I prefer to expand it at this moment. X squared plus 2xh plus h squared minus a squared divided by h. And now we get this as limit h approaches 0. So when you do that, I'm sorry, it is I should have replaced x with a, right? So let me replace x with a now. Okay, so this is a. So now this is a for us, right? So a square and minus a square becomes 0. We are left with 2ah plus h square over h, correct? Sorry for this mistake. As you know, we are actually writing a plus h. So x is equals to a, right? So that is the correction I made just now. Okay, you should be writing a, not x, okay? Now from here we can say what is slope equals to. Say slope equals to limit h approaches 0. You can take h common. So once you take h common, you get 2a plus h over h. Now these h and h cancel out. Once it cancels out, you can substitute 0 for h and you get your expression as 2a. So 2a is the slope at any point on the graph of fx equals to x squared, right? You get the idea. Now we are looking for specific tangent line which also passes through 1 and minus 3, right? So So that is what we are looking for. For that point, for that line, what is this point A? This is what we need to now find. So we have 2 points. Let's call our point P as A and A square, and we are given a point. Let's call this as Q, 1 minus 3. Now if these are the 2 points, then what is the slope between P and Q? So slope between P and Q should be, we can say this minus this, which is A square minus of minus 3 divided by A minus 1. So A minus 1. So that is the slope, which is A square plus 3 divided by A minus 1. And we know that in general, slope of any tangent line to this graph is 2A. So we can equate these two to find A. So that is the whole idea. So from 1 and 2, we can say now that 2A should be equals to A square plus 3 divided by A minus 1. So we'll now cross multiply to solve. So we have 2A times A minus 1 equals to A square plus 3. So that gives us 2A square minus 2A equals to A square plus 3. Bring these terms to the left side. So once you do that, you get 2A square minus A square, so which is A square minus 2A minus 3 equals to 0. Now you can factor this equation. We're looking for two numbers whose product is minus 3 and sum is minus 2. So these two numbers are A minus 3 times A plus 1 equals to 0. That clearly gives us two different values of A, right? So I squeezed in so that I have more room to further simplify and get the answer. So that gives us two values of A. A could be 3 or A could be minus 1, right? So that means there are two different points on the graph where we could have a tangent from this particular point, right? So what we have here is we could find slope for both the points. So we'll consider 2 points, A equals to 3, and then we'll consider let's say A equals to 1 later, minus 1. So if A equals to 3, then what is slope? Slope M will be 2 times A, right? 2 times 3, which is 6. You get the point. So let us first find what happens with A equals to 3. We need to find equations, so we know now the slope, and we also know that this line is passing through the point 1 minus 3, right? So we can write down 1 minus 3 as the point with slope 6. So we have y equals to mx. Mx is 6x plus b. To get the value of b, I'm going to use the point 1 minus 3. So x value is 1, y value is minus 3. Minus 3 equals to 6 times 1 plus b, and from here we get b equals to minus 3 minus 6, which is minus 9. And so we get our first equation with b is minus y equals to 6x minus 9. So that is one of the equations, correct? Now let's find the second equation. To find the second equation, we are going to use the value of a as minus 1. So a equals to minus 1. If a is minus 1, then what is the slope? M will be 2 times minus 1, which is minus 2. So slope is minus 2. Then again the equation will be y equals to minus 2x plus b. To find b, let us again use the same point, which is 1 minus 3, right? So minus 3 for y, 1 for x, that gives 2 times 1 plus b. So from here we can get b equals to 3 minus 3 plus 2, which is minus 1. And therefore, let me push the page a bit to the right. Okay, that should help. Y equals to minus 2x minus 1. So this is the second equation, which represents the equation of the tangent line from the external point to the graph, right? So that is how we should be doing it. Now, as an added exercise, what you could do is you could accurately sketch your graph. Y equals to x square, correct? So you could sketch your graph y equals to x square, and then check by sketching these lines. Do they form really tangent to the graph and also passing through point 1 and -3? I hope this solution helps you to understand the basic concepts. I'd like you to further investigate and solve few more questions of similar kind. I'm Anil Kumar, and I hope with my examples you should be doing very well in your test. Thank you and all the best.